You've learned how transformers work in theory. Now let's see where they actually show up. From chatbots and code assistants to image generators, speech tools, and multimodal apps. We'll connect the math and models to the real products you use every day. So far, you've covered the fundamentals, explored attention and transformers, and gotten hands-on with Hugging Face and prompting. Now we're shifting to the so what phase. How these ideas power real NLP, vision, audio, and multimodal systems in everyday use. Transformers matter because they give us one general engine for many kinds of data. Text, images, even audio can all be turned into tokens, passed through the same architecture, and adapted to new tasks. Because the computations are highly parallel, they scale well to massive models and datasets. Once pre-trained, the same core model can power translation, chatbots, image generation, and more. In this course, we'll stay focused on how these models behave at the task level. Transformers first became famous by solving sequence-to-sequence problems in NLP. For translation, the encoder reads the source sentence and builds a rich representation. The decoder then generates the target sentence, one token at a time, guided by attention that decides which source words matter most. For summarization, self-attention scans the entire document, finds the key ideas, and compresses them into a shorter sequence. It's the same architecture, just tuned for different outputs, new language or shorter text. Question answering shifted from keyword lookup to true reading comprehension. A model like BERT takes the whole question and passage together, understands their context, and points to the exact answer span. When fine-tuned on datasets like Squad, it becomes very good at everyday natural questions. The same idea powers modern search. Both queries and documents are encoded into embeddings, and relevance is scored by meaning, not just overlapping words. Transformers also treat code as just another sequence. They learn how functions, variables, and libraries usually appear together, and how code structures tend to unfold. That's how Copilot-style assistants can suggest the next line, generate tests, or write boilerplate from a short comment. The same attention mechanism that links words in a sentence now links tokens across an entire code base. Large language models used in chatbots are transformers tuned specifically for dialogue. They're first trained on huge text datasets, then aligned using supervised fine-tuning and reinforcement learning from human feedback. During a conversation, attention lets the model look back over previous messages, so it can keep track of topics, goals, and tone. That's why your prompting skills matter. Every message you send becomes part of the evolving context the model reasons over. Vision transformers reuse the same transformer idea and simply change the input. Instead of word tokens, they cut an image into small patches and treat each patch like a token. Each patch is embedded into a vector, tagged with its position, and sent through self-attention. This lets the model relate any region of the image to any other, making it powerful for classification, medical imaging, remote sensing, and hybrid CNN transformer systems. The impact grows once we move beyond simple "what's in this image" questions. For detection, models like DETR treat objects as a set and directly predict boxes and labels, using self-attention to understand how cars, people, and background relate. For segmentation, the model classifies every pixel, using global context to separate overlapping regions. The same architecture extends to captioning and visual question answering when combined with language models. Multimodal transformers let text and images talk to each other through a shared language of vectors. Text goes through a text encoder, images through an image encoder, and attention aligns them in a common semantic space. Once everything lives in that space, we can move freely between modalities, describe an image with a caption, generate an image from a prompt, or retrieve the best image for a sentence and the best caption for a picture. Transformers also shine whenever user behavior can be seen as a sequence. Think of each page view, search, click, and purchase as a token in a sentence. The model learns which events tend to follow which patterns, then predicts the next best action or item. This powers product suggestions in e-commerce, what to watch next in streaming, or the next lesson in an online course. Attention lets the model reuse interests from many steps back, not just the latest click. They're equally useful wherever you need to read, understand, and respond at scale. In customer support, transformers power chatbots and email triage that detect intent, root issues, and draft helpful replies. They can condense long customer histories into a quick brief so agents see context instantly. For documents, transformers extract key fields from PDFs and forms, summarize dense reports or contracts, and auto-classify document types. The result is faster turnaround, less manual data entry, and more consistent decisions. All of this means transformers quietly show up across a workday. A developer can search a massive repo using natural language, then auto-generate docs and sample API calls. A marketer can draft a campaign email, ask for 3 alternative tones, and polish wording in seconds. In enterprises, custom models sit on top of internal wikis and tickets, turning scattered knowledge into a conversational Q&A assistant. Think about how often you touch transformers without realizing it. Your translation app runs an encoder-decoder that aligns sentences across languages in real time. Your email summarizer uses self-attention to scan long threads and compress them into a few sentences. That support chatbot at work? It retrieves relevant docs, then an LLM, guided by prompts, crafts the reply. You've seen that one architectural idea, attention-based transformers, can support translation, summarization, coding assistance, question answering, vision models, and multimodal systems. This one family, many tasks pattern is the key mental model to keep. When you meet a new AI product, you can usually ask, what kind of transformer is under the hood, and how is it adapted? Next, we'll zoom out and examine the costs, limitations, risks, and where to focus your learning from here.